So in today's lesson, we're going to be referring to section 5.2 in your textbook and talking about the physical properties of matter. Well, when we talk about, let's start with the word properties. So the word properties, usually is like, a characteristic or a descriptor. So those are really, words that we could interchange with properties. So it's like, what about it makes it that type of matter? So a physical property is basically a characteristic of the substance. I'm going to talk a little bit more about that. So we can talk about qualitative properties. Those are ones that we don't measure, that we simply identify by using our senses. And then we also have quantitative properties. You can see the word quantity in there, and hopefully that'll remind you that those are properties that you will be able to use to describe a piece of matter that you would get through doing various measurements. And I'm going to expand upon both these qualitative properties and these quantitative properties in today's lesson. So we're going to start with properties that are qualitative properties that we can use or that we can describe using our senses, right? So whether we're looking at it, whether we're smelling, and so on and so forth. So you're going to need to create yourself a little table here so that we're going to list various properties, and we're going to kind of describe it or define what it is that property is saying about that substance. So if you need to pause the video in order to make a table for yourself that's neat and organized, make sure that you do that. So the first property that I want to talk about is state. So the state of matter describes whether it's in the solid form, the liquid form, whether it's a gas form, or a semi-solid at a given temperature. So of course we know that water could be in any of these states really, depending on the temperature. So it's important when you're identifying the state of matter in a circumstance that you're describing at what temperature you're measuring it. So some people will ask me, well, what is a semi-solid, right? So it's something that sort of still has particles that can move past each other, but still sort of holds its own shape. So I think of like peanut butter, right? You can spread peanut butter, but it's still, a solid substance. All right, I'm going to move on to the next example. So I'm going to move this up just a tad. And so color, for instance, is another property. And so we want to be really specific about this depending on the circumstance. So in some circumstance, maybe the specific color is less important. But maybe you have two substances that have a very similar color, in which case you might need to use more precise descriptors in order to describe their color. So for example, I just Googled, pink color, and I came up with this. And so, there are these are all different types of pinks, right? So let's say you had 5 solids that were all pink. You might need to be a little bit more specific when describing its color. But it may not always be important for you to be so precise. Another thing I want to mention is that there's a difference between something being clear and colorless. Clear describes how transparent the substance is, while colorless describes the absence of color. And I'm going to get more into that when I talk about clarity. So the next thing I want to talk about is texture. So texture describes, well, what it sort of feels like. I guess that's one way of thinking about it. Some words that come to mind when discussing the texture of a substance, I might say it's rough. Okay, so like sandpaper would have a rough texture. It might be smooth, sort of like maybe ice can be smooth. Gritty, so I have a picture here of sand. So some sand is grittier than other sand. Fine might be like a fine powder. I thought about like baby powder is quite fine, quite gentle. It's very, very particulate. Okay, on to our next. So we would be able to identify that by using our sense of touch, and also just by observing with our eyes. So the next physical property I want to talk about is odor. Of course, being able to smell something. So it may not be as important for you to describe what it smells like as how strong it smells. So for instance, odorless is, the term we would use to describe something that doesn't really have a smell. Pungent is often used to describe a really small or strong smell, right? So like, skunk spray can be quite pungent. I think we know what a burnt smell is, spicy. Sharp, I think of like blue cheese maybe, that's a pretty sharp smell. At any rate, and just think about what the purpose is of you making that observation and decide how precise you need to be when describing it. Okay. So the next term is luster. So the physical property of luster describes how shiny a substance is or how dull it is. In fact, the fancy word, I'm going to insert the fancy word here. The fancy word for shiny is lustrous. Right? That's a sciencey word to describe how shiny something is. So for example, metals tend to reflect light really well. They are lustrous, as opposed to a lot of non-metals tend to be dull. In other words, not shiny. All right, next up is clarity, and I already sort of mentioned this before. So clarity describes how see-through a substance is, right? How transparent it is. So for instance, you might say that saran wrap is clear or transparent. You might say that, so let's put that in. The fancy word for clear is transparent. You might say something is cloudy. I'm not sure if anybody knows what the fancy word for cloudy is, but it's translucent. And then opaque just means you can't see through it. Right? So it's really about how much light can get through if it were sort of right in front of the light. So when we look at this, we would say, well, the saran wrap or the plastic wrap is transparent. Which of these substances would you classify as translucent? Hopefully the wax paper. So I'm looking at wax paper here, and even though it's not completely see-through, there is a little bit of light that can pass through it. I can still see these leaves that are underneath it. So that makes it translucent. The aluminum foil, however, is definitely opaque. I cannot see through it. It will reflect rather than transmit light, so yeah, definitely opaque. So I want to talk a little bit more about clarity earlier and versus color. So what we think of, when I look at this, I can see that it's transparent. So I can say that it's clear. But it's definitely not colorless. It's clear red. As opposed to water, and water would be clear because I can see through it, but it's colorless because it has no color, right? So substances can still be clear but still have color. So just to differentiate between colorless and clear. And though we never taste substances in a lab, the taste property is definitely one that we could use with items that we might consume outside of the science lab. That would definitely help us to describe them, right? So, sweet, salty, bitter, sour, those are sort of the main four tastes that we might talk about. So, now there are also some other physical properties that we can't really use our senses necessarily, but we can definitely get this information by performing some simple tests. And so one example would be hardness. And so often, how easily scratched a substance is or how easily it's dented is a measure of its hardness. And there's actually a hardness scale for all sorts of different substances. And diamond, we know, is extremely hard, whereas if I took a piece of chalk, I know that I could squish it and create a fine powder out of it with minimal energy. So the hardness test is quite easy to do. Now, here is, the next one is malleability. So I'm just going to pause the video and recenter. So malleability, so whether something is malleable or not, that really describes how easily we can take a solid and hammer it into thin sheets. It's really a way of describing how bendy it is. Will it bend or flex without breaking? right? So here you can see in this little animation here how they're taking this metal and they're able to twist it in various ways, and it doesn't shatter, right? It's still flexible, and that's how we make those posts, I guess they're balusters that go in staircases. So we would say that substances like aluminum foil, and most metals for that matter, are quite malleable. Whereas, a substance like glass, we would just not describe as malleable. We would describe it as quite brittle because it shatters quite readily. There's not a lot of flex in glass, in most regular glasses, that is. So the next two properties are ductility and crystal form. So ductility, that word really just describes, it's very much related to malleability. It's how easily you can take a solid and draw it into a wire and essentially form it into a wire. So we would say, we know a lot of copper wiring in your house. So very ductile material, right? We can form it into a wire. So you can see how malleability and ductility are sort of related. We would say glass is definitely not ductile. It's quite breakable, except perhaps like fiberglass. All right, next. Crystal form. So the crystal form, it turns out when you have a liquid that slowly solidifies, depending on the liquid that is, it will form sometimes these crystals, and those crystals can have different shapes. So it might be important if you're examining a solid to distinguish it from another solid that looks a lot the same by looking at its crystal form. So for example, salt is a white crystal, it's a white powder. But there are a lot of white powders that are out there, and so maybe the one way to distinguish between the salt as opposed to another crystal is by simply to examine it under a microscope or using a magnifying glass and identifying its crystal structure. So another way we might be able to describe a substance is by how soluble it is in various solvents. So water, we know, is a very common solvent. Water dissolves a whole lot of things. So a good way maybe to distinguish between one substance and another is to describe how well it dissolves in water, for instance. So the example that I would say would be, salt we know is soluble in water, pepper isn't. Of course, there are other characteristics that we could use to differentiate between salt and pepper, but certainly there are a lot of white solids that look like salt that are not soluble in water, and so that might be another way that we could differentiate between salt and another substance that we have yet to identify. So viscosity is probably my favorite physical property. I just like it because I think it's a really obvious one to kind of, when you see it, it can be difficult to describe certain liquids because they may look very similar. Here we have three clear, colorless liquids or solutions with clearly different viscosities. So viscosity describes how easily a liquid flows. So we would say that maple syrup is really viscous. Think of it as like sort of thick. Like corn syrup is viscous, molasses is viscous, but water is not viscous in comparison to maple syrup. Water might be considered viscous compared to some other liquids that we might encounter. So it's all sort of a relative thing. Here we have three different liquids, each with a different viscosity. And so viscosity really results from, we've been talking about particles, viscosity results from friction that occurs as molecules are sort of slushing or sliding past each other. And so that creates the viscosity that we see. Because, when we think about friction in other circumstances, friction really just slows things down. It's no different for particles of matter. So we have two more physical properties to talk about. So we can describe substances, we can perform simple tasks that allow us to know the melting and boiling points of various substances, right? So we know what melting and boiling point means. but we can certainly differentiate between two substances by their boiling point. So for example, in today's experiment that we did with the ethanol and the water, ethanol, I believe, has a boiling point somewhere around, I want to say, 78 degrees Celsius, whereas water boils at 100 degrees Celsius. And so, just that sheer difference in boiling points would allow us to differentiate between water and ethanol. Okay, so lastly, density. And we're actually going to be doing a whole other lesson where we calculate the density of a substance. But density, some people think of it as like the thickness or the softness or the hardness. It's really just the amount of matter that you have in a given amount of space. So we can measure that in grams per cubic centimeter, grams per milliliter, but we see that we have the amount of matter in, so the mass, grams for instance, divided by the volume here. And so we'll be doing some calculations with that. Let's think about some examples of some dense substances. So lead, we would say, is very dense. In fact, we use it when we're having x-rays because it doesn't allow the x-rays to penetrate very easily. We would say that feathers are not very dense, right? We can kind of see that by how quickly or how much they're affected by air resistance when we let go of them, when we allow them to kind of float through the air. They're not very dense at all. We can think about water as being more dense than air, right? We can walk slowly through water, but we can walk, quickly through just regular air. So those are some physical properties that we can identify with our senses. I've also listed some physical properties that we can identify by performing some simple tests. On Monday, when I return, I want to do a lab with you. It will be an informal lab, not a formal lab. And so that will be fun, a good way for us to practice identifying the physical properties. So make sure you come to class on Monday knowing or remembering some of the details of these various physical properties. But for now, I would like you to work on these text questions found on page 182 of your textbook, numbers 1 to 4. So pause the video for a second now. Work on some of these questions, and then when you're ready, I want you to continue the video because I have more to talk about. So the next lesson that I want to talk about is 5.3, and in this lesson I'll be describing what a chemical property of matter is and also how it is different from a physical property of matter. So physical properties of matter basically describe the substance sort of on its own, right? So characteristics of it on its own, not interacting with any other piece of matter. When we talk about a chemical property of matter, we're talking about how it reacts or interacts with another substance. Whether it becomes a new substance or not, we're describing how it interacts with that other substance. So often what we'll do in order to identify the chemical property of a particular type of matter is we will create a situation where we react it or, put it next to or in close proximity to another substance under some specific set of conditions. So let me give you a couple of examples of chemical properties, and there are many. So in class on Monday, I'm hoping to show you some of these. So the first property would be combustibility. So I think we know what combustibility means generally speaking, and we can describe whether a substance is highly combustible or is non-combustible, and both of those still describe the physical property, or the chemical property rather, of combustibility. Okay, so we would say that propane gas is quite combustible, whereas water is not. Water is not a combustible material. It does not catch on fire and explode. So let's talk about reaction with an acid. So we know that we can describe some substances as being quite reactive with acid. That is their chemical property, whereas other substances do not react with acids very well at all. So for example, zinc. Zinc is a metal, and most metals will bubble and react when exposed to an acid. But they won't. Most acids will react with metals But metals won't react with a chemical opposite of an acid, which is a base. And that's why drain cleaners like Drano are not really acids. They're bases, because if they were acids, they would eat away at some of your pipes, reacting with the metal in the pipe in some older pipes. Anyway, there are many chemical properties of matter, and they differ very much. So, and we could talk about them for long periods of time. The main point of this lesson is I want you to be able to identify something as a physical property, which describes that substance on its own, and a chemical property, which describes that substance when it interacts with another substance, whether it actually does react or does not react with that substance, and how it reacts or doesn't react. So here's some other suggested homework for you. On page 186, number 3, that question's aimed to get you thinking about the difference between chemical and physical properties. Please jot down any questions you might have about the lesson, and we can discuss when I return to class on Monday. Have a great weekend.